Welcome to this video. I'm going to explain how to use VS200 software. The Olympus software has two versions. The first version is the freeware Olivia, and the second one is ASW or application software version. That is a licensed extension of Olivia that allows to control the microscope and modify some of the images when you acquire them. Um, First of all, the most practical way to set up a sample is to open a notepad such as this and write down the batch that you want to scan. So the stage we're using at the moment has a number of pockets, and you can set up 2 or 3 batches during your experimental session. What I normally do is I separate the batches in 3 of them, for example. That will make you what normally is a sample collection. So put all of that information into this notepad and save it into a easily accessible folder into the desktop. For example, session training, where you're going to save this file as the date, right? Okay, so for this section, we only have one section. Name of is TSJ2KB and is set up in Pocket 3. So we open ASW software. At the moment, we have the computer, the microscope, and the reflected light lamp switch on. Therefore, we are good to go. We will do acquisition in 2 different magnifications. The first one is 4x and the second is 10x. 4x is going to be very quick, so that will give us some time to explain you some of the things that you can be playing with during your session in the software. The microscope can be used in 6 steps. So the steps for using the microscope are currently 6. And we will describe them during the course of the video. Good. So the first screen that you will encounter is this panel, and it will tell you if there is any problem with the software recognition of the microscope components. There is this bug because we have updated the ASW software. So to fix it, we just only have to click in additional layouts and then go to acquire devices interfaces and then click OK. That will reboot the instrument and it will fix the problem. The steps that we will follow are what you just saw. Reboot the instrument devices recognized by ASW. Step 2, enter your sample in tray exchange. Step 3, calibrate. Brief checkup of the calibration and so on. So save always. And now this has finished, you can return to scan and you will see the main menu options. We are basically working with batch scan mode and very rarely with single scan mode, although in single scan mode you can use it as a digital caliper, whereas in batch scan is more for scanning 6 sections at the same time during the tray exchange. So the tray exchange can be done with this, and we click it. We enter the sample into the tray until the tray inserted LED in the house panel in the front is turned as green. Now we will wait a few seconds until that updates and close the instrument door. A few notes here. The first is that you don't need to calibrate the instrument. That will be done by a specialist working at CARF. Second, that clean objectives uh, are not necessarily applicable for us because we are not using oil immersion methods. But it's good to know that the microscope can clean the objectives if they are designed for high magnification and high uh, light intensity experiments, such as 100x, which will be interesting. Then you also have this last scanned images option, but it will only show you images that have been stored in the main disk we are using for this microscope for storing the database, and the recent image folders as well. So these two are for local storage, and you will see, but we don't care about that because we are working basically with the server. So click into batch scan once you are happy with the calibration settings. But in step 3, we will have a brief checkup of the calibration settings. So before doing anything, click into additional layouts and come back to manual control, where you will see all of the microscope options for the camera and for the microscope control. So here we need to click live. That will automatically point us to the sample in the pocket tree, as you can see with the mouse pointer. And you can drag this box to explore your sample in more detail if you want to. You can also change the magnifications with these options here at the top. And in this checkup, we only need to see if a case of cross-polarized light illumination is correctly configured. To do that, we need to go to the border of the sample, such as this. And if there is light passing through the border of the sample where you have the epoxy at the glass, you will need to change the polarization angle. So far, I think 133 or 143. Between those values, you will find the maximum extinction. So let's try. Yes, let's do this. 113 is a good value. So once you are approaching the correct value, get the histogram to be very close to 0 at the top of the dynamic range. And once it's very much lighten up, decrease the value until you get much better extinction. 107, it's a very good compromise. So set 107 and apply these same settings for all of your microscope control modes. Click OK, and then fix this once more as it was before. So now you are done with the calibration. You can stop live and return to scan here at the top left tab. Now step 4, do a batch scan. Here you will see that all the pockets are recognized. So we need to apply one specific settings for batch scan. In this case, we will want the sample at 4x. And because it's pocket 3, we have to define the batch content to contain only sample 3. To exclude all of the others, I have pressed the control key and click on the different samples. So confirm, and then go to edit scan settings. we have to see here that the all 4x has been selected. Right now we are looking at the detailed settings of scan, but we are going to do only the overview scan. There is next step to do the detailed scan, and you can also set up where you want to save and what's the name of the sample at this step. So the first thing is to set the name of the sample. Here we just have to copy paste the sample name. And the second thing is to define where we want to save it. As I said, we can log in into the database with the credentials you will be given after the training session. And in the database, select the folder specifically where you will want this image to be saved. In this case, the sample is of vals, and we create a new folder, the sample in January, for example. He can then edit the name of the folder. Sample January will be the destination, and this will be updated. You can now proceed with the full pocket scan and use the minimum magnification for making an overview. The bright field modality, it's a good option to this step. And the initial set position has been set up for you prior to this. So don't care about that or the exposure so much. In very special cases, it's important to check up the exposure levels because some samples are different. They don't allow light to come through, so we will need to use reflected light instead of bright field. The microscope basically works by acquiring frames. The frames can be placed in different areas of the sample, and they will calculate a distance in the set axis of the microscope. Hi. Now you have to make the definition of the scan area, and you will shrink this square to be on top of the slide, and don't care about the sample detection algorithm that will mark up everything in green. You can hide it with this button here, and never click into the AI neural network recognition because it's not calibrated to geological samples. Then the focus map will show you where are the areas that will require detailed uh, focus distance calculation. And depending on your sample, some samples will have a high topography, therefore you will need to have more field. So you can go extra high, for example, and that will give you more fields for the calculation of the focus map. That will change depending on the magnification because the field of the area is going to shrink as you increase the magnification. But it's a good compromise to use high for 4x acquisition. For anything but 4x, you will need to use extra high density for the focus map. It takes a few seconds. We can see that there is a variety of mineralogy that will require to have exposure settings to be set up as constant values, and that will be automatically done for you. Here, for example, you have listed the modalities that you want to use, including reflected light, plane polarized light, and cross polarized light. They all have specific settings, such as the white balance, shading corrections, distortion corrections done by the software itself in the background during calibration settings. And we only have to list them using this button on the top left, where you can select what orientation of the stage rotation you want to use. Either if it's cross-polarized light, you will have 0 to 90 degrees total rotation, considering 90 is equal to 0 degrees, and in plane polarized light, you will have 0 to 150, but in fact it's 180 because 0 is equal to 180 degrees. You can grow this list way larger but it's not necessary for most of cases and in this magnification as well. Um, be sure to have the reflected light at the top because this is the channel that will be used for measuring the focus map. The distancing and the focusing is much better achieved when you look at the surface of the sample. Although you cannot necessarily put it in the final image, so if you click here, the image in reflected light will be used for focusing, but will not be included in the data tree when you finally have the file output. So we don't click here, and we just go on with the acquisition. We can also do the different set planes levels. In this case, we are only using one image plane, but we can also use virtual set acquisition. And here we have to define what depth at the sample we want to get. Samples in thin sections are 30 microns. We can, for example, put 30 microns range, and that will calculate automatically how many planes you will have. But because we're using 4x, the depth of field is quite large, as you can see in this equation, and therefore we have one step. But if you use a 20 or 40x, you will have a smaller depth of field, and the multiples of that value will give you the number of steps with a simple equation. You can also acquire an extended focus image, which is just uh, condensing all the information in all the set planes and into one image that has maximum sharpness. And in here, the maximum intensity projection, it will take the same input as the virtual set that you have acquired at different set levels, but will produce an image that calculates the maximum pixel values for every position. Normally we use normal. If you use virtual set and you have many steps, that will multiply this list by the number of steps. Therefore, your image file is going to be very large. For studying circons, we normally want to use the set plane count to have 5 or 7 steps, for example, but very small set range. Therefore, you need to use the 40x magnification. Good. All of those steps are calculated relative to reflected light, focusing at the focusing plane calculation. Therefore, this one is very, very important. The exposure of the camera is set up at this level, but it will depend on your settings. I do recommend not to change this. If you want to change it anyway, you can start live. That will take you to the sample specific frame you're looking at in this overview, and you can drag the field of view to different area of the sample where, for example, you will do autofocus and then one-time auto exposure. So this will allow you to calculate what's the better exposure time for this reflected light mode. And you can also change the camera settings. If you do manual, for example, and you change the gamma value, instead of 1, you use 1.48, the contrast within the silica matrix of this sample will be much better, but you will risk, for example, overexposing. If you see at the top left of the histogram, the pixels in the very reflective phases. Therefore, there is a compromise and you have to check up for the best settings possible. You can also set the camera settings to be normal. I do recommend do that. And then if you need something boosted in contrast, then use the manual settings and adjust the gamma and the brightness to balance out what you want to see. Normally we start with doing normal, and also the exposure shouldn't have changed, but uh, if you want to change it and to adjust it to a better value, just find them. Therefore, we are ready to stop live and start the scan. This is going to take 5 minutes approx. At the beginning of it has to estimate the time remaining for the scan. That is done by knowing what is the large dimensions of your sample and making an estimate of how many fields are inside. and not only fields but also microscopy modalities and set planes if you have included set planes. It's all exponential, so the more detail you want to acquire into your sample, the file size are going to grow very quickly. The fields that are scanned at the beginning are the focusing of the focusing plane. If this fails, you have to restart your sample settings from the beginning. We have set up batch scan in step 4, and step 5 is going to be uploading to the database, and then optional downloading to local PC, and step 6 is producing set stack. The batch scan at 4x takes approximately 2 minutes to complete. At 10x takes approximately 5 minutes, more or less, probably 8 minutes, 8 minutes each. And to that, you have to add the time to upload to the database. So now it's uploading to the database. If you click and show upload status, it will show you a summary of when it was started, when it was finished, if it has been successfully uploaded to the database, and or if it has been saved into the hard disk drive where it's located in the computer. This is the file progress that you need to follow up. For 10x slides, it takes longer to upload. But all of this is going to be done simultaneously. You don't have to wait for the batch scan to finish. For sample 1 to 5, to keep uploading to the database. So it saves time. You can see here the summary of what has happened, and close this. You can go home now, clicking into the house at the bottom right, and because we have saved it in the database, we will need to go to the database, clicking at the top right tab, open the database, qt VS200, exclamation mark is the password for those who want to access the high advanced configuration settings, and then go to the folder where you save it. In this case, is this image. You can click the image in the directory and then go to database, import export, export database, export documents, and save it into the folder you just created for the training, session training. Click OK. This will predict what's going to be a file size in your computer. Click OK. So this will definitely paralyze the software for a few minutes. Because we're working at 4x, it's not really bad. At 10x probably take you 5 minutes to download the image. If you want to monitor what is the speed of the internet connection, you can press Ctrl Alt Delete, go to the Task Manager, and in the Task Manager, go to the Performance tab, where you will be able to see the Ethernet speed if you click, and the speed we have to the proxy server is around 100 megabits per second. It might increase if you upload many files at the same time to a limit of 150. This is the memory consumption. We will monitor this in the next step, where we are going to produce the set stack. It's important to watch that the memory is not overloaded or close to be overloaded, so that we don't risk freezing the software and wasting our time. This can be of very much of importance when we are using 20 or 40x. So it has finished. It will tell you that was successful, and go to the file folder where you save the image, and you can open it. In the image processing tab, you will see the image once it's opened in your local disk file, and you can navigate this image, but it's not much of interactive as using a set stack. Therefore, we recommend following this procedure of extracting the layers from the image data tree, and that can be done individually. We are finished with extracting the layers. We can now go to image, combine frames, and in here we select the set dimension for the procedure, and then here we have the order of the image acquisition. Select all of them and click OK. There is a way for you to see the progress of this. You can go to View and to Tools, and then here, well, anyway, you see now what is a set stack. You will have a slider at the top left of the image, and it will change the rotation angle of the stage virtually. Save the image, go into Save As, and select the folder where you save it in your local disk. You can save it in export and name it as the original name of the sample, J2KB underscore set stack, in the format of the VS200 microscope, VSI, and that will take a few seconds to complete. While this is taking place, you can already be closing some of the images. not all of them. Okay, now it's completed. You can discard all changes from all images. Close all, discard all changes, and that will finalize our session for today. To finish using the instrument, you have to exchange the trace. Take your sample, close the tray, and close the software. This data can be saved into external disk. Thank you very much. I hope that it was helpful. If you have further questions of this workflow or suggestions, please let us know to Vals or Marco. Thank you.